So here are just some preliminary thoughts I have about the question of do the diagonals from the corners of a regular polygon all equal one another. So first of all, here's a regular polygon. All the sides are equal. This is a hexagon. It has 6 sides. And then I've just gone and I measured the angles. I've drawn in the diagonals from the corner to the other corners. And I've essentially measured the 4 angles that I've created. And you can see over here they're all equal. Of course, that's not really a proof because, what if this doesn't work for 7 or 8 or 9 or 10 or a 1,000-sided shape? So that kind of got me thinking a little bit more about, like, maybe I could put a circle in here. And so I can draw a circle, just like take 3 points here, and I can inscribe any polygon with a circle. And then I'm kind of thinking about angles a little bit more, and I feel like if I draw these segments in again, oops, if I use my segment tool and I draw in, say, this segment here, and this segment here, and then maybe this segment, and this segment, and I'm just going to try to think about comparing these angles. Oops. So this angle and this angle. Of course, when I measure them, if I measure them correctly, they're equal. But the other thing to kind of think about is they're both tracing out the same amount of distance along the circle. Since LM is equal to KJ, the arcs KJ and LM are also equal. And I feel like there's some kind of idea, but again, I'm not proving it very correctly, that the angle that subtends an arc, if the arc lengths are the same, the angles are the same. And so then, since this is a regular polygon and all of these arc lengths would be the same, then I think we can make some kind of argument that all the angles are going to be the same, but that feels not very worked out and not very elegant. But that's a start, and I'd love to hear what other people have to say and think about